feel like where I'm coming into maybe my problem is between string and character, and string to character.
Okay.
Changing types.
Yeah. So let's do this. I want to share the work they had done.
Yeah.
So we'll point the screen share over here. And Will, if you just like airplay it, we'll talk about it. Cool. Yeah.
Wait,
I need to come in on Saturday.
I just watched that last year.
Now, she said you remind her of Eddie Bernard, which I don't see it. Right? If you remind me of anybody, it's probably Guy from Office Space.
I think that is a very high compliment.
Yeah.
You know, I've never seen Office Space.
That is a damn shame.
I
That is
know.
awesome.
It really makes me program.
Yeah, it's
Oh, it's a great movie.
Really?
Say what? Sorry? Oh, yeah. Yeah. So, lecture canceled. We're watching movies. Would that be awesome? Remember when you were a kid in elementary school and like they rolled that TV in?
Yeah.
Yeah.
Yeah, except in health class.
Because they were you watched.
They brought like the Miracle of Life and stuff like that.
Oh yeah.
I was absent that day.
I'm feeling sick. But on my stomach can't go to health class. All right, Will. Let's discuss. First of all, it looks like you're not calling your capitalized method, man.
Oh, yeah, I don't know.
Well, do you have a test?
No.
Okay, so you got rid of the test.
Yep.
Okay. So we don't know what this method is going to return because.
I'm such a dummy.
It's going to return, I want it to return the number of capital letters.
Yeah, but we don't. When it returns, we're not going to like let anybody know about it. It's just going to return that number and then end. Right?
So we can system out, right?
Yeah. So we need to like have the program show us the output of the what's it called?
I feel so stupid.
Did you see like what you need to do?
Yeah, pretty much. I just like saw it.
So there you go.
That.
Yeah. So run that crap, man.
Nice.
What does it say? I can't even read it.
0. So it didn't work.
That seems like not the right answer.
That's not correct. All right, hold on, wait. Let me figure this out. Let's see. Capital character is uppercase. If so, then plus caps.
Actually, yours looks exactly right.
I don't know, man. I pretty much just copied yesterday. And like, let me think.
Oh, duh. I see what's happening.
Oh wait. Hold on.
So what type is I?
I is an int.
It's an int. So on line 14, we say if character that is uppercase and we give it I,
Yeah.
it's converting I to a char, actually, and then that char is some random character you don't know about. So you don't need I, you need the character at I in the string.
So it's char at.
Yeah. Well, strings have a method, an instance method called charat, which you can pass in an int and get a character. Let's use that. Let's use input dot input. Since it's an instance method, we're going to use our object and call a method with just like that. So do you understand what's going on here, Will? We have a string here. We have a method on strings, and each string is called charat. We can pass it a number and get a character at that element, right? We run it again, and we get 2, which seems like the right answer.
It is the right answer.
It is the right answer.
Perfect. So let's see. So I was an int,
Yeah.
and we wanted a string.
The reason why the compiler wasn't screaming at you is because you can actually convert ints to chars. You can cast them, the parameter types. So it was like, okay, I'm going to take this int, convert it to a char silently, and then give you is that case. That char equivalent is nothing we care about, right? That's just a random number to char conversion. Right, because remember how when computers store files, we see them as letters, and then what those letters are actually numbers. And those numbers are actually a series of ones and zeros that goes into the processor, right? So in Java, a number can also represent a character if you cast it like 1. So if you're like char at 4, I think 41 is capital A. So completely arbitrary, right? But your algorithm here is spot on, right? You did everything else correctly. It's just that one little thing tripped you up. So Will here on just focus on, Will, he, on line 10, he has an int caps equals 0. It can imply that that's the number of capitalized letters. And it's starting out at 0 because we haven't found any at this point. And then we have a for loop here. So we're starting at I equals 0, where I is going until it reaches the end of the input length. And we're incrementing I, right? Does that make sense so far? And he's using the is uppercase method. It's a static method on character. We're passing in a character we're getting at the element of the string. And then if this returns true, we're incrementing the number of capitalized letters. That counts. And at the end, we just return that count variable. So that's the number of capitalized letters we have in the string. Good job, Will. Well done, sir.
So, did you just say that in English or code language?
It was English mixed with code.
Codish.
Yeah, it was like English code.
So, do you mind if I attempt to speak in English?
Absolutely. Do you want to come up and talk about it?
No.
No. Okay. Okay. All right. You're gonna sit there. Okay.
Move your.
Hold on, I'm testing something out.
Will, stop moving stuff around. God.
Now I scaled it.
All right. So you create main class,
Mhm.
and then you print the line base number if it's capitalized. If
Hold up. Time out.
He prints the number of capital letters.
I'm printing this method.
okay, so you print the method when it runs. Okay.
Yeah, I'm passing based on answer the method.
Yeah. Capitalize is gonna run, and then the output of capitalize is gonna be dropped into this called a print line. In this case, it's gonna be 2. The number 2.
Why is
It's inside the parentheses here. So like, Will, if you do me a favor, can you select all this text inside the parentheses here and cut it out? Okay. So we could say system.out.println like 3 or 4, right? That wouldn't really tell us anything meaningful. It's just that we're printing out a random number.
right?
Now, what we can do instead of putting that number in there is give it a function that returns a number.
Right.
So if we call that function, what we'll get back is a number, which we will then print using println. Right?
Okay, so basically that line is testing what is capitalized.
Yes.
In the, okay.
Yeah.
So in line, whatever, 6, it's printing out which letters are capitalized when you paste that back.
Yeah.
Using the function capitalized. Then the public static int is there to turn whatever is capitalized, whatever the input, the string input is capitalized into an integer.
Int here specifies the return type of our method.
Okay. So, and the return type is an integer.
Yes.
And then of the string input. So then int caps equals 0.
Oh,
You're defining the integer.
Yes.
I'm just defining caps here.
Why are you defining it at 0? Because it starts with 0.
Because it's, you have 0 caps, and then once we go through this for loop, you're increasing the number of capital letters each time it sees one.
Got it.
So I
So
actually had a
the
question about
baseline
that.
is just always 0 when you start the process of int.
By default, an int is 0.
Okay,
Yes.
So would you have,
But
So,
in this case, We want to set it to 0 logically because the problem we're trying to solve is how many capitalized letters are there.
Right.
And if we make a new int, by default, we can't say there's like 1, because we haven't found it yet, right? So we have to start with 0 to solve the problem.
Okay, in order for it to return appropriate.
Yes.
So then you run a for loop using the int. You run a for loop, and that for loop includes the syntax for the I.
Yeah.
What do you call that?
This is just
Stuff in there.
this is just the declaration of a for loop. There's no real name for it.
So you declare the for loop.
I is the iterator.
That is actually exactly right. I is the iterator
Okay,
in the
so
for
you
loop.
declare the iterator in the for loop.
Yeah.
And when you have I is less than input.length, you are counting whatever the length is, and you're saying that I is less than whatever that input's length is.
Okay. Let's make it a little bit more clear.
Okay.
Okay, let's take a time to step back. Let's talk about the syntax of a for loop. Okay. So inside the parentheses next to a for loop keyword, we have 3 sections. So we have this section, the first section, this middle section, and this last section. Okay. So in this first section, what we have is an initialization, right? So we're initializing a variable I equal to 0. Okay. That's where we're starting from. We're starting with I is 0. The second one is a condition where we will stay in our loop. So we're going to stay in our loop as long as I is less than the length of our input.
Okay.
And then this last section is what to do each time we loop. In this case, we're adding 1 to I.
Let's say you wanted to skip 5 letters. You could do I plus or equal to 5, right?
Yes.
So like you wanted to just look at every 5th letter.
So then you run an additional.
You said I equal to 5.
You declare the method character.
We didn't declare this method.
You
Call
call
it
it.
anything.
Guys, can we not talk while Joey's trying to explain this?
Are you calling it?
Yes, we're calling the is uppercase method that exists on character class.
Okay.
And is uppercase returns either a true or a false, which then gets dropped into our if statement. And then if that's true, then we do that, which adds 1 to caps.
So is that caps plus plus related to the I because you define the integer as caps, right?
These are both integers. I and caps are both integers, but they're not related to those in there.
Oh,
So if you think about it, like caps is 0, right? So we have like something that's not in the string yet. Caps is 0. It's just there because it's what we want returned. It's a number that we want returned, right? So that's the number of capitals. We don't have it yet. So like the I will go through each letter. So it looks at each letter, right? And the character is uppercase, input character at I. So the I is just looking at each of the letters. Character at, like if when I looks at that, then just add a number to the character integer.
so is that what the function of the plus plus is?
Yes.
The purpose of the plus plus in any situation is to
Add 1.
Yes.
Yeah.
and then you return caps.
Yep. Because after this for loop,
Integer that you declared.
Yeah. So after this for loop finishes executing, caps is going to contain the number of capitalized letters that we have, which is solve the problem. So we return it. Yep. Yes, Mike.
So if in the for loop, we went int I equals 5, and then ran it.
You can't do that first of all, because you'd be redeclaring I and it already exists in the scope, so you can't do that. But if you could reassign I, in which case you put yourself in a really precarious situation.
So like he's starting at 5 right now.
So he would start at the 5th letter and then go 1 by 1 from
It
the
would
5th.
not, well, depending on the length of the string. So yeah, this would be a weird thing to do, so it might be confusing. But if the length were greater than 5, it would start at the 6th element in the array, right? Because the 5th index is the 6th actual entry, so it starts at 0. And then it would give you all valid things from that point in the string.
Yep. So when I started it at 5 now, it just gave me 5 and 7, 7.
Yeah. So, but if the string were shorter than 5, then that loop wouldn't Put it all,
Hmm.
right? So that would be terrible.
Yeah, I mean, my question is more like, is it gonna go by fives or is it
No.
gonna start at five and then go one by one?
This, in this initialization block, we're only determining where I starts.
Okay,
So if this just says 5, I just going to begin at 5.
Okay.
If we wanted to say, let's go up by a certain amount, we would do that here.
okay, so then it would be I plus five.
I equals I plus 5, or I plus equals 5.
Plus, okay,
Yes, Joy.
got it.
So if I were to rewrite this question so that I could do it during this day, so I could get checked at the end of the day, would it sound like this? Write a function that accepts, I mean, this is like exactly. Write a function that accepts a single parameter string and returns the number of A's included in the string. Could I equally do that?
That is about the same level of difficulty as this problem, yes.
But it wouldn't have anything to do with capital.
Right, no, I-
It's the same class of
That
problems.
contains A's.
Yeah, you could do that, and that would be good practice if you want to do something similar to this. Yep. Are we cool? Does everyone understand this whole approach? Cool. What I want to do now is share my screen. What's up, Luke?
You guys both have your Iron Yard shirts on today.
Heck yeah, we do. Iron Yard's awesome.
Did you?
Did we what?
I thought you said I called him.
Oh, yeah, he totally did.
First thing I did is send it.
Hey, Ben, what are you wearing today? Okay.
Will, do you think that you're competent enough to check over?
Yes. I think that I'm competent.
Well, are you competent at all?
Will, are you a bad enough dude to check her work?
Yeah, I'm an expert at novel.
So sorry, viewers and future YouTube viewers. I'm trying to share my screen real quick. Okay. So what I want to do is go over the solution I came up with. And first of all, show you the test, what a test looks like, okay? So I have two tests here. It says capitalize returns the number of capital letters and strings. In a professional environment, the test names are ridiculously long. Exactly what they test, right? And so what's going on here is I'm calling main.capitalize, and then I'm comparing that to two capital letters, return 2. This test will pass, right? B, C, D, E, this will return 5. It should be equal to 5 if it's so on and so forth, right? So we have one implementation here, capitalized. It's basically exactly the same as what William had. A slightly different approach.
Okay. For loop, syntax,
Yes.
is that over like the starter
Yes.
and the, okay,
Specifically to Java, it's not many other languages.
okay, yeah, it's awesome.
Normally, what you want to do is just get that element at an array, and they just took that, like, since people are doing that so frequently, they were like, we'll just give you the element. But if you need to use the index in some case, then you've got to use the other for loop syntax. It's just much easier to use, right? Like if you wanted to use I for some reason, like in our one of our assignments, we had to print out the index of the element, the regular for loop for that, because.
So how, can you explain the for loop here? Like what is that for the other one?
Well, this is really functional. Oh God, this is really functionally equivalent to the other one. It's just here, check it out. So this and the other for loop syntax, it would be like for int I equals 0, I is less than input dot length.
Yeah.
Do that for now. And I plus plus And then we'd say char c equals input dot char at I, right? So at this point, these are the same, right? So since people were doing this so much in the beginning of their for loops, is assigning c to the current elements, they're like, why don't we just give them that char instead of making them access an array element, that index syntax, to allow you to do that more concisely. Mm-hmm.
So, that's taking
Oh,
giving a char array.
It's going to iterate over every character in the character array from the string. String into a character array, keep in mind that traditionally strings are just big arrays of characters. String hello world, it's really E next to an L, next to an L, next to an O, next to a space, next to a W, next to O, and then a slash and a 0.
When I first started thinking about this problem, I was thinking about getting the characters,
Mhm.
but I didn't really know about this particular method. I split, and then I was like, oh, that's all it do.
It's a little bit much for this problem. You can get away with not converting to a char array here because you have the char at method that's on string also. Char at. That was the method you used.
Oh, I had it wrong.
Oh, okay. Oh, yeah. Sorry. That's right. My bad.
Is it possible for you to scroll up just a smidgen?
Sure. What do you want to see? You want to see that?
That's the test.
What is what I ran the test on? I actually ran a test on both of these guys. This is my test.
I also did a stream.
Oh, yeah? Does it look like this? So this is
Well, sort of.
a cumbersome thing to map between chars and characters, by the way.
Math C, the chart C, I just cast it in the design piece.
I love that syntax, it's so cool.
So basically what happens is we get a string input, and this is complicated. So we get the input, we get the characters of the input, we map them to character, like, because this chars actually returns integers that represent the characters, and then we map them to actually pass it into filter. Get the amount, the number of things that are. So sadly, we have to convert that to an int at the end. That returns the same thing. Do that hard mode though, and study if you want to later on. And so be it. What you should really focus on is really understanding this guy right here. Cool?
Colon there. What is it, colon, do to RC, RC?
It's an alternate for loop syntax. So way to write for loops and is the same as other languages. Java gives you this one as kind of a helper because people did this so much. So like traditional for loops in almost every programming languages you'll ever know will follow this syntax between lines 25 and 27, right? You'll notice that in order to solve our problem, the first thing we did in the for loop is assign character equal to our interested in, right? Since we needed a reference to the current character with respect to our I variable. I followed this pattern so frequently, just nice way to write this and just say where we're like, give us every char C that's in our char array. And then make this I variable. If this feels uncomfortable to you, to use it.
Well, I'm just curious to know what the colon, how colon relates to input that char.
Just it specifies that syntax for the for loop. It's not specifically related to char array specifically. So it just basically says we're going to have a char C, and then what we're going to iterate over is input to char array. Colon is just the syntax for how the for loop specifies here's our variable and here's our array. So specifically related, it's just that's the collection we're iterating over. If you don't feel comfortable using it, it's not required. You can get the same number of problems done with the original for loop syntax, and it does make more natural sense at first. Cool? So right now, oh God. So I'm gonna go open up iTerm again. Code, August 2016 directory, Scratchpad, type git status. We're going to add everything we've done so far, commit it. Now it's all on GitHub. So now you have a reference to everything we've done so far in Scratchpad. So, for today's lesson.
Yes, Java FX.
No,
Oh.
that was yesterday's. That's old stuff. New stuff is libgdx.
I love Java FX.
It is a pretty cool library, especially if you consider what we used to have, which was Swing, which is terrible. So libgdx. So I want to begin today's lecture with a video on kind of what is possible with libgdx.
Oh,
Here we go. It's gonna. So I just want to point out, IntelliJ is right there in the center of the things that you love in Java development. Validation.
cool. I like IntelliJ.
It's movie time, Mike.
You can make this?
Yeah, libgdx is a wrapper for a library called OpenGL, which is what powers a lot of video game development. We're going to get into today. Not this.
Oh
No.
my God, this is cool.
This is an example of what someone has written in libgdx.
It's pretty.
Yeah. Well, I mean, how it looks is entirely up to the developer. They can make it as complicated as they need to. This is a big deal. Ingress, Niantic Labs, they recently released an app called Pokemon Go.
Oh, that's
Right.
awesome.
Before Pokemon Go existed, they had another app called Ingress, and apparently it was written in libgdx. Okay. The realm we're dealing with. All right. Technology stack looks like, what you can do with it, right? So, I thought that was a pretty good intro to what we're talking about today. LibGDX, let's open up our lesson. Download that setup app. It's not very big, but it's still useful to have before we get into class. I learned my lesson about downloads. It's all party, and I basically crashed everything. So let's open up the app. It's not right. Go away. So it's possible that you're going to need to one trusted developer. So keep in mind that today we're just going to follow along with a series of instructions. It's not important that you understand the why behind everything right now. We're going to go through a small little journey, and at the output, it's going to be a neat little thing that you can run and play around in. Okay. So try not to get hung up too much. Try to keep yourself like what we're kind of doing. If you ask them, that's totally okay, because we're delving into a territory that is actually pretty deep. We're just gonna like take a glimpse at it, right? We're not gonna like to it, right?
What's iOS Go? Is that on Apple?
Yeah. Sure, honestly. Specific thing, I'm pretty sure, because what you can do is publish I saw in the video you said you could publish to anything. That's got to be like one of their publishing targets, where you can publish to specific versions of iOS devices. Honestly. All right, so we're gonna call our project Hello Game with the package com.theiron_yard. So we're gonna name it game packages com.theiron_yard, right? And then we're going to uncheck everything here but desktop. So we're only concerned with making a desktop application. We're going to uncheck all this stuff. Okay? Extensions thing. We don't care about any of it. Actually,
Except for desktop.
except for desktop, yeah. This destination thing, this is important to note. You're going to have to be aware of where it goes. I would probably put it in your code directory somewhere. This is going to dump like in a whole big project in there. Move this to the trash.
What does SDK stand for?
Software Development Kit. So that lets you, it's like a framework for, it's like a series of classes you can use for development.
Actually, can I too?
That's a good time for a bathroom break. Yeah.
Should I make a new file inside my code?
Yes.
Yes.
You mean folder?
Folder.
Because yes, you should.
Yes.
Otherwise, you'll dump everything into your code directory. You don't want that.
Okay.
How do you make a new folder? In Finder, there's a button here at the bottom. Like if I go to my code directory, let's see. That's actually a really, I'm pretty sure that there's a button up here. Yeah, if you can find a way to, yeah, here we go, new folder. It's up here in that little gear. It's kind of weird that I didn't know that immediately. I thought you could be able to right click on the, you can now. Two-finger tap an empty space in the folder, and you can make a new folder in there, which is probably what I've always done. I can't really tell you by default, though, without even thinking about it. So you're like, how do you do that? And I have to think to my brain, how do you do that, brain? And you're like, I don't really know. people are watching. And people are taking a bathroom break right now, so we're going to begin class again when they come back. Yeah. Import from external. We're not there. We're not there yet. So, they can. If you want to hit import from external model, make sure you select Gradle. So, all of our stuff application, setup application. What I'm gonna do is generate a bunch of code, whole project structure, and dump it into a folder in our file system. The thing is this Koalio directory. Well, actually, we're not doing Koalio first. We're doing Hello Game. Let's just do Hello Game for now. Wait a second. I'm stoked about, so that's the reason why I did that. Let's see, and make sure this doesn't exist. All right, so we're going to click generate.
EA files.
Nope. We could probably do that, but we're going to be using the IntelliJ's import project feature instead.
It says it's downloading.
What it's going to do is use this utility called Gradle to install our libraries that libgdx project depends on. So Gradle is like Maven. We've discussed Maven briefly before. We're going to get into Maven in more detail later on in the class. Gradle is another. So we're not going to interact directly with Gradle today, but we will later in the class.
Mine looks different than yours.
In what way?
Mine's still downloading. That's why.
Okay. Well, I think maybe I cached my packages the other night, so loaded from my local repository. What's up, Will?
Okay, cool.
So you're still working? Still chugging?
Yeah.
All right. When it's finished, okay? Like, you know how, like, with progress or
It's
anything?
doing dots.
So when it does finish, do is import our project that we generated with the libgdx setup app into IntelliJ. So I'm gonna go ahead and do that. If that's okay with you guys, because
I mean, I guess.
no, okay. That's boggling my mind. It's taking so long though.
Is everyone else done? Yeah, why? I don't know.
Will still downloading. Mike, you downloading?
Mine said build successful.
Okay, you're done.
Is yours?
Will, Joy, you're all finished?
I think it says done.
Yeah.
Import to IntelliJ.
She's already like 2 steps ahead of us, so.
Keep going on.
Nah.
Yeah, you will. You're working so sharp.
I won't remember.
I know.
Okay.
I'm the expert, so.
Yeah. Wait. It really is kind of boggling my mind though. These libraries aren't that huge. So that's weird. But
Mine's still loading.
Like, how many megabytes are these?
tens.
Like, tens?
Yeah, it's still not very big.
That's pretty.
Yeah. In the meantime, let's talk about what OpenGL is and what libgdx. OpenGL is a classical, it's been around for forever. OpenGL is a library that is used to write video games, essentially. It's a graphics drawing library. It's a C library. And I think there is a distribution of OpenGL that libgdx wraps around. So basically, someone created libgdx to allow you to write in whatever programming language you want with an OpenGL, what's called a binary, right? Tells what the OpenGL binary to do, and you write in your own language. So essentially, it's like for what OpenGL is, but in your favorite language. In this case, we're dealing it within Java. Code that looks very similar to OpenGL code. Patterns OpenGL set forth.
Can I show you something? I think I might have.
Sure, yeah.
So I just deleted this, but I think, because I had downloads right next to that before that, that's going to go to my downloads. So that's going to be a bad.
I mean, like, it's going to be in that hello game directory, so it should be fine.
Under downloads though?
I mean, that is a weird place for it to be, but it's not going to cause
Because I don't have, I have that on my desktop.
Okay, so we have another folder on your desktop, but you have one also in the downloads directory?
No, I don't. I just didn't.
It probably created one. If you open up downloads here, yeah, see there's a hello game.
Okay.
Yeah, so it's doing its job. It's just the end result's going to be in your downloads directory.
Okay.
Which is a little strange. Say what, Will?
So you can move it after it's done.
Oh yeah, you can do that too. Okay, so OpenGL is actually major competitors. OpenGL and DirectX. DirectX is like a Windows-specific thing, and OpenGL is kind of the open-source alternative to DirectX. OpenGL is kind of on its way out. Last time I checked, it might have made a resurgence. The indie game scene, like indie games are kind of a big deal now. Like you talk about Steam's Greenlight or whatever, and lots of cool stuff with that. So, but your major titles, they rely heavily on DirectX. Yeah.
Mine is too.
Got like 7.
Yeah, mine too. It's yours.
A lot. I used to play Counter-Strike a lot. You guys remember that game?
Yeah.
It's built off of Half-Life. That was built in
I think my
OpenGL.
brother-in-law plays that.
Counter-Strike Go. Yes. That means you guys almost done?
It's speeding up right now.
Okay. I should have told you to run the setup app last night. That's what I had the foresight to tell you to download an app, and it was like just a few kilobytes, and then like
Yeah, I was like, wow, that was so fast.
yeah, and then now this is taking forever, so that's great. So let's go ahead and just import it. I think you guys are going to be there soon. We're going to go to new and project from existing sources. To the folder that we stored our output in. So this is going to be, forget, hello game. Okay.
You said import, right?
No, wait, no, not import. I'm sorry. New from existing setting. Yeah.
Mine's still not downloaded.
Okay, so when I clicked,
I don't have that either.
Just hit new. You hit new. Hold on.
it would actually be in IntelliJ.
Yes, you do have to open up IntelliJ.
Yeah, I mean,
Apparently I confused IntelliJ right here.
Project from existing sources. Still downloading.
Man, this freaking dependency downloading is taking.
It's still going.
Wow.
Me too. Why is this taking so long?
Sorry, guys.
Yeah.
So it's not new project, Joy, it's new project from existing sources, okay? Right, select, send my game, hit OK. Our project from a Gradle model. Gradle in this, we need to make sure we specify that. Selected by default, you just need to click this guy instead.
So you need more product?
Project from existing sources. Imported, I believe, but this is how I'm choosing to do it right now. The directory that is holding everything. Directory in the libgdx setup app, you need to hit that directory.
Still downloading.
Here it's import external model.
Yes.
Click that. Great.
Yep. And the defaults are fine.
Message two.
That's fine.
Okay.
Yeah. How can I assist you?
So I go to close. Went to import.
Mhm.
And here's my build Gradle, right?
I'm still
No,
going.
sorry. Import something, you need to do this parent directory here. So I don't know, this is actually kind of strange because this code directory you would think should be holding all your code.
IntelliJ.
Mine is
So I just
still
put it in the
going.
wrong place then.
This is in code
So-
hello game. Everything right here.
For libgdx.
Yeah, so that's what we're gonna code hello game. You maybe ran this program twice?
Yeah.
Okay, so what we're gonna do is use this one that's inside the code directory.
Okay.
Is that okay?
Sure.
Okay, so we're gonna import this hello game. Import from an external model, Gradle.
Interesting. So I have to do it.
I know,
Yeah.
mine too. No.
Okay.
And this is where it was before. So then just click OK.
Yes.
It wasn't.
Cool.
Mine came up with that and yours didn't.
You're just finished?
Oh yeah, Mike.
I don't know.
It's okay. It's perfect actually. Okay, so we have our IntelliJ project open.
I don't.
You can still import it.
Can you? I can try.
I don't know if I would.
I don't think you can.
I guess I'm not sure what the ramifications of that would be.
Because it doesn't have anything to import. Or I'll import it. Might put me back even further.
Yeah, never mind. I did it, but then.
You guys can't believe like in your laptops. It's like
Seriously, and mine's brand new.
it's not your laptop necessarily. It's just the. What network are you guys on right now? Are you on the 5 gigahertz
I'm
network?
Charlotte.
Are you on the 5 gigahertz one?
Oh, no, I'm not.
So
I think there's a lot of interference on the lower frequency, so you might want to.
Okay, so what's that one?
Yeah, it's the same password. You mean to type it out?
yeah,
Got it.
Do you remember the password?
you know,
Code and E300.
Yeah. Yes. But it's also the L is capitalized, the T and the C are capitalized.
Gotcha.
So if you change your network right now, it might mess up your download.
Oh, man. Oh, wait. Wait.
Did it,
Yes!
it finished?
Yeah, total time, 12 minutes.
Yeah, that's not fun.
Done.
All right, cool. Guys,
Okay, so new project from existing code.
or you can click import. Yeah, let's just stick with what we know.
Name.
there's a second button.
Yep. I got it.
sticking with us, adoring fans.
I like game Gradle. My chair squeaks. It's way more comfortable than that other chair.
I think that's actually,
It's really nice. I like it a
Yeah.
lot. I think it's one game Gradle.
That one.
still looking Will. It's been a long time.
At some point.
Do you feel like,
Changing networks?
I'll stay for a while, and I was going to just start back.
kind of want to,
It's unzipping.
all right. So-
Wait, I'm gonna get that.
Here's what?
Now I'm stuck on the building.
Done. All right, so
You're done, Will? Great. Yes, import from existing sources.
what's the special things that you click?
Use existing model Gradle.
Getting new.
Or external Gradle. Okay.
So yours is,
Like after I click,
oh, that does take a little bit. How long has it been like that?
for a long
Like that. And then you're-
Is there like a window that maybe popped up if you command tilde? Does anything, leave it alone. Should just work. Wow, this is not what I expected to take a long time today.
And it's such a cool project. Like,
You don't even know. It's gonna be awesome. Pretty mind blowing, actually. There's another one we're gonna do just after this. It's even cooler. It's yeah. All right. Okay. They're explicitly written out in the lesson. So as long as you get the gist of what we're saying today in class, the lesson, if you have trouble, then we'll talk about it, okay? All right. So we have our project imported. What we need to do is build what's called a run configuration for libgdx project. By default, IntelliJ did this for us when we had our standard Java projects, but in this case, we have to tell it exactly what to do. So we're going to go to run and then edit configurations. So go here to the run, we have edit configurations. A new application. It's going to be the name of our desktop class. So the name.com.theironyard.desktop. Yeah. There is a class that is responsible for launching an app on our desktop. As our main.
lowercase desktop and the uppercase, I can't see everything.
Yeah, that's the package, and then the class name is desktop launcher.
No, we're getting through the iron yard. Desktop launcher?
No, libgdx is generation of that.
Okay.
That setup app we ran, stuff with the parameters we pass into it. Okay. All right, so we have that finished. So let's check it out. So the main class will be desktop launcher. The working directory will be the core assets folder. So we go here, the working directory called core. And inside that there's an assets folder.
Wait. Pull that up quick.
Ellipsis here. Browser. So inside hello game, which should have that selected by default. Folder, and inside that there's an assets folder. Yeah, that's going to be the working directory. So the working directory specifies when we run this run configuration, from where are we going to run our app? Our app inside this assets directory.
Okay.
Which might seem a little strange at first, but yeah, it makes a couple of things easier later on. Okay. Your facial expression is like, what's going on?
No, I just, because I couldn't figure out how to make a new file and so I saved it to the desktop.
Okay.
So, we good.
So the next thing we need to specify is the class path module will be desktop main. So use class path of module. Configuration is going to use the class path with one of these modules. We haven't dealt with a project that has multiple modules yet, so hopefully you understand this. Basically, our modules has a specific class path when we run our code. All right, okay. So we have a run configuration. So by default, if we click the green triangle here, or we hit Control R, app pop up.
Oh, cool.
By default, this is Bad Logic Games, the company that produces libgdx. This is just a red square with their logo there, right? So it's, right, so we didn't make this, making this for us.
But it's still cool that it popped up.
Yeah, it is cool. There's up to your Apple logo here. You can go to force quit shortcut, but I always get confused as to what these things mean. I think it says Alt button. So Alt Command Power button is a shortcut for force quit, but I usually just go up here. So what are you force quitting right now, Will? IntelliJ. Okay, man. I'm worried, but I'll just let. Good luck, man. Sorry. Man, I'm sorry everyone's having so much trouble getting things just working here. So, what we want to do next, this image move. How do we do that? Right. So let's open up our class MyGDX_Game. This class was generated by default with, again, the libgdx setup application.
Well, how'd you just do that?
Commando. Navigate to any type in the Java.
GDX game?
Yeah, I just type in my.
GDX game.
Yeah, and it auto completed my GDX game, hit enter. So now I'm here.
Okay.
Yep.
Have some exceptions.
What exceptions would this say?
The file bad logic.jpg phrases is using deprecated carbon.
That's fine. That
Mine
part's
said
fine.
that too.
I would specify, did you specify your working directory as the core assets folder? Check that.
I'll figure it out.
Mine says that as well. Everything comes up.
Yeah.
Yeah, me too.
Same.
So I expect the first error message regarding
Yeah.
this. That's fine. That's just a warning. Not a big deal. This is in the future. Use will be deprecated, but we're not worried about the future right now. We're just gonna do a cool app right now. So we're not worried about that warning. Or will affect how you load your image though. Everything?
Yeah.
Okay, good. Make sure that works. If it has a red square with a picture of Bad Logic Games in it, then you're good to go. So you can see here that MyGDX_Game is a class that extends application adapter. Okay, so this is our base class for your game. This class is an abstract class that has a series of methods that they're like event handlers. So this method is going to be run when the object is created, when the app is run. This method is going to be run when the app is resized, and it has this render method, which is run like once every second. It's going to run render over and over and over again. There's a pause method and a resume method and a dispose method. So if you want to get rid of any resources, this dispose method exists. Pause and resume if you want to pause and resume your game, right? Focusing on are going to be create and render mostly.
What's that one in?
Adapter, and I got there by clicking, I command clicked it, so I could just look. I could show you the methods that exist.
Okay.
So it's up to abstract classes are very similar to interfaces in that you have just a series of methods you need to override. We're interested in, we're just going to override here. What to do is create this class called a sprite batch and a texture here. Right? So we have sprite batch, and texture image. So this, when we create our application, we're going to initialize these variables. Rendered is this. GL clear color is going to specify background color of our application. GL clear color is RGBA, is red, 0 green, 0 blue, right? And this is just color, basically. And then we're going to begin using our batch operation to draw the canvas, essentially. And full understanding of what's happening here is not a necessity. The general grasp of what's happening, but essentially it's going to draw this image starting at 0, 0. See, begins at the bottom left-hand corner of the screen. Image is 0, 0. And since we specified red, it's red. We wanted to change this to purple. We change that to a 1, and so it would be red, green, blue. Yeah. Okay. That is make it move. So how do we make it move? So we have to change the X and Y position of the image that we render. Is the same as what we had before, as the create a new sprite batch, an image to a new texture object. But we also have to store a float X and Y, which are the positions of the image we're rendering, okay? So let's add those fields to the MyGDX game. Single precision floating point number. So a floating point is like a decimal. We've used doubles mostly.
Yeah.
So twice the precision of floats. Use doubles, but in this case, we're just concerned with not too much precision, so we're going to use floats. A different type that stores the same kind of data. Is that cool?
Yeah.
All right, so you know that there's ints, and there's doubles, and there's chars, and stuff like that,
Yeah.
and booleans. Like integer can only go up to a certain number, right? So like the maximum number the integer can go to is 2 billion, right? So if you wanted to store like Bill Gates' bank account balance, it wouldn't be big enough. You couldn't use an integer, right? Because it would do this thing called, it would wrap. So it would actually give him a negative number, which is crazy. But in order to store bank account balances, in that case, you'd have to you change the type from int to long. Is twice as long, essentially, as an int. Way more numbers.
So what does that have to do with float?
Because float and double are, like, a float is to int. Float is to double what int is to long.
Okay, all right, I gotcha.
So if you wanted a very precise floating point number, you'd use a double. Precision as much as we care, just about point value.
That makes a lot more sense.
Okay. So X and Y are the fields. They're going to store the current position of our render. Every time we render, we can change the position of our picture by 1 and Y. We have X plus plus and Y plus plus, right? So check it out. Instead of passing 0, 0, it's our coordinates into the image, we're going to pass X and Y. X to see the image do when we do this. Manner should it move? Just right, diagonally.
It should move on a diagonal every.
Yeah.
Every 60 seconds.
It's 50 times every second.
Oh,
Oh,
okay.
cool.
So, yeah, that'll be impossible.
Mine says arrow.
Sorry.
I got it. I just forgot to send my homework.
I'll get you. Yep, there's no limit to where it can move. It's just gonna keep going ad infinitum. Okay. Ad infinitum at that thing. Next, I think it'd be cool if we added a keyboard input, change the direction of where the image is moving. So that's also possible. So let's encapsulate all our movement logic into this move method. Okay. So it's going to take this, find what move does. We have let's see, look at a private variable. We have private void move. Okay. We're going to use a method to our movement code. Okay, so we're going to replace our x++ and y++ with a call to move. Okay. So move, it's going to have to change x and y, just like that previous. But we're going to base x and y off of keyboard inputs instead of just saying let's add 1 to both every time we render. So check it out. GDX gives you, the library GDX gives you an interface to handle keyboard inputs. So this GDX class is an input field. You see, if you take a look at GDX, it has all sorts of stuff. We have a reference to what we need to process audio. We have networking. We have file I/O. OpenGL libraries we can reference. And we can reference as well. Graphics type, which is like a graphics context. So you just kind of like a little bit. So this is like a method that will return true if this key is pressed.
Coming up right.
The input class. So just highlight over it and hit Alt Enter. Yep. So input.keys is a class keys that has just basically is a bunch of key mappings here. So these are character values and their mappings. It's going to be like if you push enter, that's 66. So basically we're going to pass a key value here, and the is key pressed is going to tell us whether or not that key is pressed, essentially, right? So if the up key is pressed, add 1 to y. We're going to add subtract 1 from y. If right's pressed, add 1 to x, and if left is pressed, take 1 away from x, right? Every single time, and is like a bunch of times. Like it's consistently repainting things to the screen. Render is the meat OpenGL application. Like it just will run constantly. So if render takes a long time, it's a huge impact on your performance of your application. So you want to make it as quick as possible. So we run it. Our image doesn't move. However, we can go like this. What? By the way, and the image is moving around. Doesn't go down a lot. You can't. It doesn't stop moving when you stop pressing the arrow keys. Oh yeah. Well, sorry, I did that without talking about it. Yeah, you kind of have to remove the x++ and the y++, or you're gonna have trouble keeping it where it needs to be. Yeah, that's a good point. All right. So we have is key press set, and we're moving x and y based off of that. And then our render call at x and y. Velocities. So floats here, we're going to say x velocity and y velocity are also things we want to keep track of. So we'll add that to our class up here. And xv and yv. Just type it. Apparently my copy and paste skills are okay. All right, so we're going to also introduce this constant here called max velocity of a certain velocity.
Max velocity is called uppercase because it's a
Question, Mike. So this is what's called a constant. And what makes it constant is we can't change this value because we marked it, like you said, as final. By convention, people capitalize their constant variables. This is a relic from C and C++ programming days. So you'll see that this doesn't follow the same lower camel case naming conventions we typically use. It's name, or it's word underscore word. So that's usually the convention you'll see with constants.
Okay, so if it was 3, it would go underscore word again.
Yeah, yeah, yeah.
Velocity plus.
Yeah.
So, okay.
If you, like when you see this in code, caps variable or field, you kind of know that's a constant.
Okay.
Yeah. It's just like lower camel case is the convention for variables and fields. Okay, so we're gonna get a little mathy on you here. When you do OpenGL, it's a lot of math, So we do have a decelerate function we're going to use. So since we have a velocity, we want to be able to stop eventually. Decelerate function. Let's make it here. We have private void decelerate. So decelerate in a specific velocity, it's going to just a little bit. New velocity, which is just slightly slower. So the deceleration constant we're using here is 0.95. So like if you pass in 1 as the velocity, it's going to be 0.95, and then it's going to be like this, which is like probably like point. I don't know. But if it's less than 1, we're going to go ahead and set to 0. So like if the velocity is just less than 1, it's going to be 0. Otherwise, this function could take forever to complete. All right, so that's what decelerate does. So we're going to update move. Okay, so we want to. So if we're going to go up, we're going to go up by max velocity. All right. Instead of incrementing the distance, like x is the distance that's in a coordinate plane, right? We're updating the velocity. And correspondingly, if we hit the down key, we want to go down, we'll go down by 1, right? Go down toward the screen. Correspondingly, we have xv and yv. I'm just going to copy this stuff here for. We have x, v, and v here is times -1. Okay. Move method, we're setting the new velocity of our image. This way, by max velocity, we hit right. This way, by max velocity, up. This way, right? So in math, or physics rather, remember that velocity equals distance over time, which is the amount to change the position of our image plane. It's actually velocity equals distance over time. It's velocity times time. We have the velocity function in the GDX library called getDeltaTime, which shows you the amount of time that has passed since the last time it rendered a frame. It gives you the distance that this image should travel this frame.
cool.
Right.
That's so cool. I just spit, sorry.
It's okay. As long as you're far away from me when you spit. All right, so we're going to increment x and y. How fast we went times between this frame and the last frame, which is a very small number, right? And then we also want to spend some time decelerating x and y. Next time render runs, it's going to call move, and if we're not hitting an input that's one of these, it's going to pass through all these if statements. It's going to increment, and it's also going to decelerate. Say, like, stop pressing an input key, it's going to slow down and stop instead of just stopping immediately. So let's run our code. You just see it like float around, right, and then stop moving. Power
Mine's not.
math.
It's still going off the page.
Did you remove your plus from your move or from your render method?
Yeah, I did.
Did you include a call to decelerate move method?
Yes. In my move method, yes, it did.
If you want to bring your computer over here, we can take a look. But
So.
what, Joy? Sorry? Yeah, but that's okay. You're on the right path, and that's exactly like that's freaking awesome. Change. Great idea, and we're going to do it as soon as I'm done talking to Lindsay about this. Because you can take a look at the reload change classes thing from before. Remember when we saw Notch do it? We can do it ourselves. Okay. Here we have move. That's good. Also good. Up is x plus or minus 1. X is what it's called. So that old.
This isn't private.
It doesn't matter. That's
Okay.
fine. Yeah, it's not. That's fine. That should be it. Let's rerun it and see what happens. It works. Why? Yeah, everything works fine.
Weird.
I don't know why it wasn't working before, but
Wait, go up all the way?
that's fine.
Oh, okay. I thought I was supposed to stop.
No, we haven't.
Okay.
We would have to write that in our code to say stop moving
Okay.
if we
All
hit
right.
the top of our screen.
Okay.
So we haven't done that. So yeah, if you keep hitting the arrow keys, your image will disappear because
Oh,
it'll
then it
go.
was fine.
Yeah. No, there's nothing. Yeah, good. Yeah, it's okay. That's fine. Instead of. Okay. So Joy just mentioned something that I'm super excited to show you, and I really want to try out because I think it could be mind-blowing. Is debug mode. So we're running our application in debug mode. In order for debug mode to work properly, we need to change a method. So let's change our decelerate method. Okay. It'll be super exciting. So let's change our decelerate from 0.95 to like 0.5. Right? We'll go here to, I think it's it's reload change classes under run.
Change classes.
Yeah.
Reload change classes.
Yes. Yep.
Where's my reload change class?
It's under run.
Yeah.
Reload change classes. You'll see it. So let's do something that violates the laws of physics and increase our velocity when we say we're decelerating. So So we reload our change classes and we do this. Ah, God! It flew off into nothingness. That's not what we want, right? Let me run this again.
So take your finger out.
Ah!
So now go into decelerate.
That makes you happy. Let's change that back to 0.95 so we can decelerate like normal.
Change this to like
Whatever.
and then
So you can see how useful that could be if you build a gigantic OpenGL application just to reload the change classes instead of rerunning your entire app.
I want to move faster, but not that fast.
Exactly. The limitation of the reload change classes, though, is that you need to change a method body. So you can't do something like change a field.
that's the whole point. So you just leave the one window going.
Okay,
So you don't need to like.
Thank you so much for bringing that up, Joy. Otherwise, I would not have talked about it. But I think it's awesome.
okay, so.
It's not. It's not. It's not coming back. It's gone forever.
5, and then I go to run.
Okay, moving on.
So now that we'll have the new
Is it? Alright, that's not like that.
0.9999.
See, the biggest thing you'll notice, like, I changed the decelerate function to actually accelerate my image. Visible because it zoomed away.
So
Great example. Do that.
Okay.
All right, so we're done with that. Break already. Otherwise, I would say let's take a break. Instead of taking a break. Are you playing with the app right now?
Yeah.
I actually just got mine to build like 2 minutes ago. So I'm not opening it.
Okay. Sorry, Will.
Take it back.
I mean, get started on Super Koalio. Okay.
Oh, I'm there.
Set? Perfect. So now that you've finally downloaded your project and everything works, we're going to start over. Sure, this time you're on the 5 gigahertz network. I'm pretty sure it has a lot less latency than the 2.4 gigahertz network because we have so many wireless networks here around us. All right.
Learn to code in caps for each word, and all the E's are 3s, A's are 4s, and O's are 0s. And then an exclamation point.
Okay, I'm gonna write it down. To code. I'll learn because I'm smart.
Yeah.
There.
That means we have to create a new.
We need to set up a new one application. Yep. All right.
So project setup.
So we go to our downloads again, and we rerun that GDX setup jar file. Go here and do Super Koalio. Video game that's pretty famous.
Super Mario.
Yes, you guys should be detectives. All right, so user's been downloads test. It's not going to put this in the same directory, but new user's been code Super Koalio.
Put it in the same file as or folder that we did.
Put it in a Super Koalio folder. Folder is up to you. I have my Super Koalio folder inside my code directory because that makes the most sense to me.
What?
No, it just happens to be where my cursor is. Deselected all of those. Generated, it should be a lot faster because your Maven packages should be cached.
Built it.
Taking time at all. Exist on your hard drive in a hidden directory somewhere.
Wait a second, but it didn't.
Add it to your thing. Well, we still have to import it into IntelliJ. Remember that.
Like my folder.
Did you have desktop selected?
Same deal, right?
Yeah, I did it
Yeah.
now.
No, I'm gonna do new from existing sources. I'm gonna, instead of clicking hello game, I'm gonna go to Super Qualio. So excited to show you guys this. You have no idea. All right, so Gradle, just finish. It's fine for now. Open up your project. Okay, so just like before, we need to set up a few things. Before we had to set up a run configuration. So let's go ahead and do that. Configurations and then application. So just con.theironyard.desktop.desktop launcher. Working directory is core assets folder. And, I'm not stopping for anything.
Yeah, no.
Done.
What are we doing? Go back to edit configurations.
Sorry.
Add.
Yeah. So just like we did before, yeah, we have to specify a main class for our run configuration. That's what to run when we run this configuration.
Launcher.
Use
Okay.
FlashPath,
Yes.
the main class, and that's all you need to run.
And,
Right.
okay.
We need to set the class path, set the working directory, and set the main class. The core assets folder.
Okay. Or
Oh yeah, that's a good idea. Change the name to
super duper.
run thingies. Super Qualio. I don't know, just whatever. You name it to whatever.
Okay.
So when you run it, just like before, let's confirm that we get what we had before, which remember was a giant, not giant, the bad logic logo on the bottom. Did you say nope? You say nope. You said nope
You did that
the first time.
correctly.
Mine, same thing.
Yeah. right.
No, and I got a lot of red.
Yeah, exception and thread.
Are you guys still running your application in the other grid? Okay,
Yeah, I think so.
what's that? Just to make sure.
Okay.
It shouldn't collide, but that's the only thing that's
Same thing.
different.
Yeah.
So what's it saying? Over here, we can take a look at it. It's the same steps we did before, right? So, yeah, so your working directory was not set. Just set your working directory to core assets.
Oh, okay.
Well, your issue might be different than Lindsay's. Yeah, that works. Yep. Show me your problems. In your case, you must have made a typo with your class name. Super duper, come up the internet desktop. The ironyard.desktop.desktop launcher. Yep, yeah, I need your desktop main.
Desktop. Yeah, core main. Okay. All right.
This core contains the launch. Okay, yeah, there you go. Jennifer.
I get this when I press press.
Specify the class path module. So when you have multiple modules, in order for it to run, you need to specify which one's class path to take when
Oh,
you
this
execute your
one.
program. Yes, so we just, yeah.
So when you say extract it into core assets folder, that means the things that were in that zip file should be now. in
Yes.
core assets.
So the next step of what we're doing is downloading the assets for Super Qualio, which Joy is one step ahead of us yet again. So there's a zip file here in the lesson. You click that. Open up the Show in Finder. What I'm going to do is take these assets that are here and copy them into my assets directory. So code, Qualio, Super Qualio. That's made that sometime previously. So core, assets, paste.
Or shift? Just select them all?
Command A, yeah.
Bad logic,
The bad logic stuff.
Copied all these into,
Assets folder inside Super Qualio. What is the project root? That's the level folder that is in our project. And then inside core and then assets, we have our Mike, you have the not good face on your face.
Yeah.
That's the face that you have. I'm not sure it makes any sense.
Yeah.
Are you able to progress? So once we have those assets in our folder, we can then use them, right? Look at the set assets. Sad, they're awesome. So we have core assets. I just had this folder open. I'm going to open it up again. If we look at what they are, you can see here we have this koala. We have the koala in different states of existing, right? So we walking, right? And we also have a tile set, which we'll get into in a little bit. MX file, which I believe is a count file, but we're not going to get into that depth today. All right, so let's open mygdxgame.java and make it display the koala bear with a blue background. So let's do that first. So we have mygdxgame like before. Remember that GL clear color specifies the color. Command O. Yep. mygdx clear color. Let's set it like half red, half blue, or half green, and mostly blue, right? Yeah, 0.5, 0.5, 1, 1.
real quick.
Yeah. And then the rest is the same. We're just going to draw instead of, actually this is, we're going to draw our stand image. Here we have, which I should probably go over first. So we have regions, whereas by default we have image. We're going to add stand and jump. This is going to break our reference here in our create method because we're not using image anymore. So we're going to save two constants just beneath our fields. Just so you know, these specify the width and height of each little dude in our sprite folder. Rather. I'll do that we looked at in different states of walking. Sprite.
My texture region is red, as it's supposed to be.
To import the texture region class.
Where batch draw is, should I?
No.
Okay.
So we have two variables, stand and jump. So on create, we're going to work instead of just saying we're going to specify a texture specific to of tiles. So check it out. About arrays yet? Now is as good a time as any. An array can be an array of strings, right? In which case we type like string array. But if each element in our array were a string array, would be the two brackets there. That each element not only stores an array, it stores an array. I didn't say that clearly.
String array. Array of string.
Yeah. The type that's in each element is a string. The type in each element is a string array. It's called a multi-dimensional array.
Like types.
Yeah, you can do whatever. I just chose string just arbitrarily. You can have int. In this case, we have texture region as the class. It's a multi-dimensional array.
You do like a string and an int.
Store, second, no. Learning one type. String, brackets, brackets.
Array inside of an array inside of an array.
Yes.
For that, then like to create like a multi-type array.
No.
You want to store, well, never mind. Yeah, there you go. Like for CRMs is kind of what I'm thinking.
If you wanted to be able to store anything you want inside an array, what Avery said is correct. You make an object array. However, the downside to that is that you have to every object as you wouldn't have any guarantees as to what the output object would be. So like if you wanted to call a specific method, cast that object as that class and then call that method. But then you also have to check that object to see if it is that class before you test it, otherwise you get an exception. Yeah, we talked about casting a couple days ago.
Yeah.
But we could probably use some review. All right. So again, keep in mind high level, what's going on here. So what's going to happen is we're going to load a new texture here called koalio.png. Remember that's an image, all the different little positions of our koala. He's in different states of being. So we're going to build what's called a texture region. String.split, which takes a string and splits it into an array. This sheet into different regions, multi-dimensional array. If we take a look at our super koalio guy again, yep, koalio.png. Actually, we can open up an IntelliJ. So this first element, so an important part of sprite maps is knowing the exact size that each koala takes in each position of your sprite map. So we just know that each guy is 18 by 26. So this texture region.split method is going to split this texture into different regions based off of the size we pass in, right?
That's so awesome. Oh my God.
To the cool part yet. So this gives us a multi-dimensional array because it could split it into lots of different things, right? And we just know that the texture for standing exists at 0, 0, right? So we check this out. That's the first element. And then the jump tile is at 0, 1. So 0, 1 right here, okay? Got it so far? So let's move on to render. So right now, at first, we're just going to render the koala as he is standing at 0, 0. This is how, if we run it right now, you have a let's get rid of that.
Did you just get rid of?
The image.dispose method, it came by default.
So he's just standing there.
He is standing there,
While we
really small. All right, so we're going to close this app. is actually make the koala something that's recognizable. So we have a sprite that's a certain, we want to keep that, but let's update the draw width and draw height. So we just change the size of the koala. These constants underneath height and width. Draw height. We want to draw the standing texture at position 0, 0, and the size we want to draw it as is the draw width and draw height, which is 3 times the original we specified before. So draw height.
So you take out the 0, 0 and do that?
No, the 0, 0 is still there because it specifies the position of the koala.
And 0, 0 draw one.
Can also accept 5. Because that's a different method. It's not like some magic way that it can 5. There is another draw method that accepts 5. So the one that accepts, typically the pattern is that the one that accepts 3 passes null values internally to the one that accepts 5. The one that accepts 5 would be like, if this one's not null, then do this thing. All both optionally.
Okay, that makes sense.
Yep. We ran our application and we see the koala is actually a reasonable size now. Awesome. All right, yeah, you can make them huge. In fact, you can use, no, you can't because it's not inside of a method, but
A little blurry.
it's kind of a disappointing constraint with the reload change classes that you have to change a method, not like a constant.
With it, you just do it inside of render.
So what, where?
Sorry. See just the disappointment in your face, Troy. It's hilarious. You expected that reload change classes thing to work, right? Are you doing that right now? Because sometimes it doesn't work, and it's kind of disappointing when it doesn't work. Because it's such a really exciting feature to use, right? Well, let's take the before in our other project and use it here. So remember, in order to accomplish that, we had references to not just the position, x and y, but we also had x velocity and y velocity. And we also had a float constant for max velocity.
I love it.
We actually skipped this unit last cohort because my students' laptops just not fast enough. Laptops now, so. I was kind of worried
That
that,
would have sucked.
yeah, I was considering skipping it again because we had some laptop issues, not just you, but yeah,
Well, I'm glad I got it just in time.
yeah. Several laptop situations going on.
Where are we putting that full decelerate?
The call to decelerate goes in move, but we're not there yet. Not yet.
We're about to.
So we have in render, remember render is what happens a bunch of times, okay? We're gonna call move. So we're gonna define that in a sec. Instead of rendering our texture at x, y, we wanna render it at, at 0, 0, we wanna render it at x, y, right? So we're moving all of these, like we got the decelerate and the move methods from our other project that we already defined. And add that.
Ooh, where'd you get that from?
Well, we,
Did you just do that from like the last one?
yeah, we wrote this code before with our previous project. We didn't like write it.
Right.
But we went through it line by line.
Okay.
These functions as siblings as the other functions. So we have render, create, and decelerate and move now. All right, so let's run our application as it is right now.
Accelerate is not working.
Accelerating, right? Yeah.
We were missing several things. Post haste.
Yes.
Yes.
Yeah, the accelerator will be the method.
Yeah,
We're not making a fully fledged game.
do I need all this?
As of a game,
Yeah.
yes.
Got it.
Texture to the screen, and we're drawing that texture at a specific spot in the screen, right? At a specific XY coordinate. Does everyone have a moving koala?
Wait, hold on.
So funny.
It's not even, you're, okay. Yeah, we'll get to a really cool part here shortly.
All over the
So
place.
suppose my blue is gray.
Did you add a call to move inside of your render method? To add that. So we need to update render to have a call to move, and then also to draw to the 0, 0.
He does. He slides like he's like.
Yeah, he's a sliding koala. Whee! You play baseball.
We do like ice hockey game.
Goes to first base, and then second base, and then third base, and then he goes to slides into home.
Then he's totally out of.
Yeah, whatever. Koala. Close to moving koala. I don't even know where he went. I'm pushing arrow keys now, and he's just gone. Can't. If he's gone forever, I can't expect him to come back. All right. So I just closed his entire world around him, so he no longer exists. All right. All right. So we're missing a few things. One, as he doesn't move at all, he's just a floating koala. That sucks. Also, we want to simulate gravity. Let's add gravity.
We can add gravity.
It's pretty cool. So we have a Boolean can jump because we don't want someone who's in the middle of jumping to jump, right? We have Boolean can jump. We're going to set that conditionally to true or false, depending on whether or not he's, if they can jump, which I'm not sure about midair. I would say that's not a feature that koalas have. So can jump, and we're going to specify the jump velocity, and we also are going to specify gravity. Okay.
Cats because they're constants.
The reason that we're naming these fields is because they're constant variables. The final keyword indicates that even if we wanted to, we could not change the value of these fields. It's a constant, it follows this convention. Has to change a little bit. So we want to change our key. Let's just go ahead and copy this so I can talk about it inside IntelliJ. Good. Perfect. Find the copy move down here. Place the contents of my move method with what we have here. So we updated move. So if the current key pressed is the up key, then we want to set our current up velocity to the maximum jump velocity. Is set can jump equal to false because a koala who's in midair to jump.
All right.
That would be cool for.
Just use a double jump.
Yeah, I was gonna say if we made a game where we had double jumping, then we'd include that, but we don't have that right now. Otherwise, if the key press is down, we're gonna move him down. You know, if it's right, we're gonna move him right. If it's left, we're moving left. We're going to add the gravity to the y velocity. Every time we move, gravity is constantly going to affect the velocity of the koala. Like gravity, if you go up, you're going like 5 meters per second up, reduce your velocity by an acceleration factor. In this case, we're simulating acceleration by just removing a specific velocity. Okay? So we still have the same determines how we update x and y based off of our distance velocity in our time. Remember, in v equals d over t, so d equals v times t. We have v and we have t, we're making d again. We have a conditional here. Since we have acceleration, it's possible for the koala to fall through the earth. So we need to specify that if y is less than 0, so that's our base point for our image, right? So you can't go beneath the ground. Also, when the koala hits the ground, we need to reset our Boolean can jump so that next time he pushes the up arrow, then correspondingly, if we don't type anything, we're just going to decelerate the movement of our koala. So he's constantly going to decelerate. So let's run it right now. We can see him jump around.
Oh, that's really cool.
We can add a basketball hoop. I kind of want to do that right now.
You can go left and right though off the screen.
We haven't added any code that says if you're.
I want to add a block so he can like get points like Mario. So he can jump up there.
Yeah, because you need to add the and can jump. Is that what you did? So yeah, if you push up and if he can't jump, then he's not going to go up at all anymore. It's just going to decelerate.
You can make him dance around too.
Yeah,
Like that.
we're not even. Yeah, this isn't even the cool part to me. This is about to get. It's about to get real up in here. Okay. So we have a jumping koala. That's awesome. He respects the laws of gravity. Kind of. That's awesome. Earlier, he had absolutely no regard for gravity, and that was just rude. All right. So let's move on. Is when he jumps, he's jumping. Remember in the beginning when we made this texture mapping, we had two variables. We have stand and we have jump, and we're drawing, right? So we're drawing the stand texture. So no matter what he does, whether he's jumping or standing, it's always going to be him standing. You jump, you look like you're jumping in real life, so it doesn't. You don't just like fall off the ground and fall again, right? That's not how jumping works. That would be awesome. Works. Render. We want to conditionally render the texture. In this case, we're going to specify the image we want to render. We're going to call it IMG. If the current y is greater than 0, we know we're jumping. If it's otherwise, we know we're standing. So let's go back to render. Let's update that. IMG instead of stand. So that way, we choose which one to render, either jump or stand. Again, if our position of y is greater than 0, otherwise, we're standing. You with me?
Is red.
Yeah.
Done. Okay, got it. Ah.
Pretty awesome, right? This is pretty freaking great.
Yeah, totally.
All right, but we have a couple other problems here. First of all, when we walk, we're just literally slide across the screen. Right? He's like. Also, when we change direction, there's no indicate, like he doesn't turn. He just like goes backwards. Right? Yeah, but it's even better than the moonwalk. He doesn't even move his feet. It's like he's on a conveyor belt that you can't see. It's like we're okay. Jump, which is awesome, right? So step 1 is jumping. Okay, so we need to fix those bugs. No, we didn't. We need to flip the texture if he's moving left. So to introduce that, we're going to have another Boolean where we have face right. We have Boolean can jump, and now we have face right. We're setting it to true by default. So if we're facing right, to draw things as normal. So we draw the image at the position XY. We're going to draw the draw width and the draw height. Not facing right. Check out what we're doing. The image that we currently have, drawing it at is X plus the draw width and Y. So we're flipping it horizontally, or flipping it on the vertical axis, actually. And then we're going to draw basically flip the texture around. We have batch dot draw. So if we're facing right, batch dot draw that. So this is our normal call to batch dot draw with the image. The image again is either standing or jumping. If you think of a point at 0, 0, we draw an image that is in height, right? We draw an image that's width and height. Now, we're starting at the width backwards. And effectively in appearance, but rendered like in the opposite direction. So check it out. When we run it, we're doing that. People don't have that because we didn't add it. We didn't add the switch to our face right to our. So if we push right, face right is true. Our face right is false. Okay. Right, we're going right. If we push left, we're going left. We want to face that direction. Right is face right equals true, and then left is face right equals false. Run it again.
We is Little Mario 4. Cool, that is so cool.
That's awesome. So the last thing we want to fix is the fact that our koala is still just sliding. He's like on this bottom thing, like. We want to add a walk animation. We can't double jump, but he can change direction midair, which is.
Right, so draw the chimney and that could be filtering.
To do anything. The world is your oyster. Sure. All right. So we're going to add the walk animation. Concept in GDX called animation. A walk animation. Boop. We're getting pretty heavy here on our fields. So let's add animation here. Animation. Yes, I believe so. Let me check. One that's inside the libgdx 2D package. Okay. Freaking coffee machine, man. All right. On create our application, we do a series of things. We specify what standing and jumping is. Also create a texture mapping here, this texture region. I want to add an animation. Okay, so we're setting animation equal to walk. New animation. Structure for a animation. We have a frame duration and a texture region array, or an arbitrary list of texture. The this says is that when we are walking, this guy, and this guy apart. If we look back at our Koalio guy, so it's going to render 2, 0, 3, and 0, 4. 1, 2. So him walking is going to consist of him going from here to here to here, putting his foot up here, his feet are down, and his feet are up. Right? A loop through that and consistently display him in that. Okay. We're going to jump out of the libgdx library for now, back to our code. Is to get the current time, add to the time we spent in our application. Time is going to track that, okay? Render, every time we render, we want to increment time. So time is going to we're going to add to time in time from our previous iteration of render, our previous call to render. Time is the time spent between this call to render and the previous call to render. So together we have effectively the time spent in the application, okay? So what we want to do is we want to update our for image to draw what we have here. So if y is greater than 0, we know that we're jumping, so we want to draw the jump texture. Otherwise, if the velocity of the koala is greater than 0, or it's not equal to 0, the current texture from our animation. So this, we're going to pass the time. We'll take a look at the second parameter here. Let's copy all this code into our render method. So get keyframe is a method on your animation which will get you the texture that he's currently in. Those things we passed into our animation here, right? And these keyframes times are separated by this fraction of a second. At time equals 0, we're going to illustrate if he's walking, he's going to be in this position. So he's going to be in this position. And after 0.4 seconds, he's going to be in this position. Second parameter here to get keyframe. So we're going to determine whether or not this animation loops. It does loop. We're going to hit yes. All right. And let's run our application. He wiggles his little arms, and he moves his little feet, and he jumps.
A little nose in the back when it turns.
Nose in the back?
He's so cute.
Yeah. I don't know. It looks like he's like double-sided.
He's double-sided?
It looks like it.
I've got an
Okay, we'll
issue
take a
with
look
my
at that.
animation here, and at the top I can
Right.
record it right
Isn't that
now.
weird?
You didn't.
I know.
Almost for sure.
I know. It's weird, right?
Well, actually, it'd be here.
There too.
Okay, so new animation.
I'm thinking.
Yeah, this is the wrong animation class.
New
Laptop
Yeah,
choice.
something. Yeah.
So much.
Goes back and like back.
So you included the Java FX one,
Right.
libgdx one, which is in COM, Bad Logic, GDX Graphics, G2D. Okay.
Right.
No problem. And I just ran it, so I don't know if you finished everything, but there it is. He's walking. Yeah, with the.
That's so cute.
Okay. So mine like going forward, right? And then he has 2 noses.
Walking koalas.
It looks like you did not set up your render exactly correct.
Okay.
What did you do here?
Hmm.
Right. Let's see what it moves looks like. That looks correct. Instantiate your animation. Correct. Let's rerun your application.
Okay.
That looks fine.
The back.
He's simultaneously rendering backward and left. This doesn't seem right. This all seems exactly correct so far. Wait a minute, is the animation from the right package? Let's check that. Yeah, that's the right one. There it is. Yeah, you're calling draw up here and before the conditionals,
Oh, okay.
as well as inside the conditionals. So you just need to draw, we need to call draw once. So we're gonna draw this way if you're facing right and the other way.
Okay, all right.
That should be better.
Perfect. Thank you.
Yeah, okay. Well, it's about noon, and that is what we wanted to do with Super Qualio today. I want to go ahead and make your next assignment current. Discuss it. The assignment is not to make that, so don't freak out. We rendered textures to the screen today. Keep in mind, that's what we did. We included animations later on, but get overwhelmed by the terminology you'll see here. So it says create a libgdx project called Minicraft, then download these assets into your core asset directory, and then write the code to make the player walk around. Use this to make the dude have different around, right? Around with the arrow keys, draw the correct texture based off of the direction you're holding the keys down. When he's walking, make it go faster when the space bar is held down. And when the player walks past the edge of the screen, make it appear on the opposite edge. For example, if it walks off the right-hand side, to the left-hand side. Optionally, you can animate the player's movement. Zombie texture in the assets folder. Randomly walk around, make him randomly walk around. A green background, and then draw the tree tile in a random place in the background. All of these things individually, you just have to piece it together in different ways. Okay? Good? Are your minds sufficiently blown?
Extremely gratifying.
I love this lesson, and I will definitely teach it from now on 100% of the time because it's actually. So that's it. That's our lesson for today. That's class. The rest of the day is yours for lab at lunchtime. So if you want to go out to lunch, be back around 1 o'clock. But it's up to you. The rest of the day is yours, okay? And my adoring fans, which I think might just be my wife, I love you. And if you watch this on YouTube, I don't love you unless you're my wife. All right, bye.